Hi, welcome to Stormwater 101 video. My name is Shahram Misagi and I work for University of Minnesota Extension Water Resource System and really happy to be here. Our topic is runoff rundown and I'd like to share some of the fundamental principles and issues with that's related to the stormwater and talk about what are some of the basic issues that are raised by the excessive stormwater and what are some of these problems and if there are some solutions that can address these problems. And most of all, is there really an urgency having to deal with these issues? Is there something that can wait, or do we need to start talking about these issues right away? Well, let me share with you a graphics that I have here. For me, this graphic really helps to put the whole picture in perspective. I really like this graphics. So you can see here we're looking at our planet Earth. And if I were to take all the water that we have on the planet and put it together in one spot, it would be represented by that small drop of water. It is shocking, but it is true. If I took all the water on the planet and put it together, that's as much water I have relative to our planet Earth. And that small dot, I'm not even sure if you can see that. If I were just to look at the fraction of the fresh water, that is the small amount that I have, again, relative to the rest of the water. So we have a finite amount of water that we're dealing with, a finite amount of fresh water. Another way to look at it, again, we can look at this column representing maybe all the water that we have on Earth, that would be the same as this water here. And then we can see we only have less than 3% of it as fresh water. And even that from that 3%, majority of that 3% of the fresh water is trapped into glaciers, ice, and underground. That's not really available to us. But we only have about 1% of that available to us as fresh water within the lakes and swamps and so forth. And so we can see this very small percentage of water that we have available to us is still facing a number of grand challenges. For instance, climate change, eutrophication, which is having excessive nutrients in our lakes and streams, and we also have an increased demand on our fresh water. So there is an urgency having to deal with the water quality and having to address the stormwater issues because, again, we have a finite amount of water and we want to make sure we can protect it and preserve it. Well, but the question is, well, what's the relationship between excessive stormwater, and that's the important distinction that we have to make, is the excessive. What is the relationship between excessive stormwater and clean water? For that, I'd like to share one more plot with you, and of course, I'm sure many of you have seen this already. This is a typical hydrograph. So we're looking at the hydrograph in two different landscape settings. Let's say in one area, we are looking at a landscape that's very natural. For instance, it's forested and it's open prairie and so forth. And there have not been that many disturbance or land changes. So if I were in such a landscape and I found a creek and I said, okay, let me go stand in the middle of the creek and I'm going to start measuring every hour or so how much water, how much flow we have in the creek. And I also wait for the rain. So as the rain starts coming down, I'll start measuring what is the flow in that creek or how much water is flowing in the creek. What we have seen is that when that is happening, when we're standing in such a creek that is in a natural setting, in a natural landscape, when it starts raining, it's going to take some time for the water to reach the creek. And of course, we know that that's because there's trees maybe on the landscape that are going to hold on to the water, or maybe you have deep-rooted grasses in the landscape. So when the rain falls on the ground, it gets actually infiltrated into the ground, and it doesn't become a runoff right away. So it takes a bit of a time for the water to find its way into the creek. So that's where we have a lag from when it starts raining and when we actually see water in the creek. And then we can stand in the middle of the creek and keep measuring the level of the water in the creek, and we see when we finally get to a maximum amount of the rain, it's going to take, again, there's going to be a bit of a lag before we get a real big increase in our flow in the creek. And when the rain stops after a little while, then it gently, the flow falls in the creek as well. So here we have a gentle rise and a gentle decrease of the creek, of the amount of water that flows in the water. Now let's say we get into our car and we drive some miles away and we go into a creek or a river it's right next to downtown or right next to a big shopping center with a lot of hard surface. So when it rains, the rain has no chance of finding its way into the ground, but rather finds very quickly into our storm sewer system, where it gets transported into our streams and lakes. So if I was standing in such a creek and I started measuring how much water is flowing in the creek, I would see that as soon as it starts raining, the water rises in the creek. Again, because as soon as the rain falls on the ground, it has no way of going through the ground. It becomes a runoff, and it's generated as a runoff, and it comes into the creek. So, as the more rain I have, there's a direct correlation, the more water rises in the creek. And when the rain stops, then the flow stops right away as well, and it drops off very quickly. So we can see the hydrograph changes between the natural area and impacted area. And this is this amount of water that we have here, this excessive amount of water, it is what we call the excessive stormwater runoff. And it's this amount of water, in this time, that creates much of a problem. And where our infrastructures or the national storm sewers conveyance that we have are not capable or not able to handle this, and we face a number of big issues. So what are some of these problems? Very quickly, well, again, our third plot here, some of the issues that we have, or some of the issues that are created by the stormwater runoff is, as we talked about, so we have more water generated because there's no place for the water to get trapped on the landscape or influence into the ground. So we end up with more water in our creek. And again, our system is not capable with dealing with those. So we end up having to do with flooding, or the infrastructure actually just gets blown. And we also have a lot of water moving downhill too fast, because now we have all that water that comes quickly into the creek. So we have more water moving faster, which has a lot more energy, and it creates erosion on our stream banks and washes away with it all the debris and the sediment. Well, of course, when we have sediments and debris in our water, then we have the quality of the water that is degraded. And that is how we have those three main problems that are generated by excessive stormwater runoff. So we have an issue. So excessive stormwater runoff creates excessive quantity of water. So we have an issue with quantity, too much water, and we have too much water going downstream too fast. So we have an issue with rate. And of course, as it goes down and washes everything with it, then we have a problem with the quality of water being degraded. So those are the three main problems: quantity, quality, and rate. So I know that was very quick, but that was just a quick rundown on the stormwater runoff. And thank you for watching this video. Well, now what I ask you to do is, if you could memorize and learn the three problems that are generated by excessive stormwater runoff. Thank you. Until the next video.